Alrighty then. Now that we've figured out different ways to evaluate our machine learning models, your likely next question is, how can we improve upon these metrics? And that's what we're going to cover in this next section. Section 5, which is improving a model. So let's make a heading here. We'll go 5, improving a model. Now, the thing to remember here is usually, actually, more often than not, the first predictions you make on a model are not its last, right? And these first predictions are often referred to as, let's write this down, first predictions equal baseline predictions. And first model is often referred to as baseline model. What you'll try to do is, as you go on, is once you've made some first predictions and evaluated them, and once you've built a first model, like a baseline model, you'll try to improve upon that. So AKA, improve your predictions and improve your model. And now, how can we go about that? Well, there's two main ways. The first one is from a data perspective. You'll ask questions like, could we collect more data? Because more data means that a machine learning model may have more of a chance to learn patterns within that data. And there's a saying in machine learning is, generally, the more data, the better. And it's similar to how if you were to practice something, right? And if you do a bit more practice than usual, you might get a little bit better at that thing. Maybe not exorbitantly better, but certainly if you do 10 sessions of practice, you'll probably be a little bit better if you do one session of practice. Same thing goes with machine learning, right? If there's 10,000 examples rather than 1,000 examples of something, chances are, if there's patterns in that data, the machine learning model will pick them up. And the second one is, could we improve our data? Now, this is if you had, for example, in our car sales problem where we're using the make, the color, the odometer, and the number of doors to try and predict the sale price of a car. Now, if you were given that information, it would be kind of hard to predict the sale price of that car, right? So what you would search for here is maybe more features about each car. So you would have more information about each sample. So rather than just more samples, you've got a more depth of information within each sample. And then what we're going to be focusing on is from a model perspective. And this asks a question like, is there a better model we could use? So if we look at the Scikit-learn machine learning map, we've seen an example of this before. So for example, when we followed it through and we started off with a linear SVC and we figured out, oh, those results aren't too good back in our classification problem. So then we went up and tried an ensemble classifier. And now what we mean by this, is there a better model we could use? So if you've started out with a simple model, could we use a more complex one? And what I mean by this is when someone says simple model, usually what you'll do is the models, the first ones you come across here are relatively simple compared to the ones you'll end up here. And now the reason you start out with a simpler model is because generally these models are faster to train on whatever compute power you have, and an ensemble classifier, such as a random forest or ensemble models in general, are generally considered more complex because you're training a bunch of little smaller models at once. And so this is where you'll hear the term simple model versus complex model. Linear SVC is often referred to as a simpler model, and then coming up here to like ensemble classifiers, because it harnesses the power of lots of different models, they're referred to as more complex. So that's kind of what we've already tried, right? We started off with a simpler model and then we moved to something more complex with the random forest. And then if we are trying something more complex like an ensemble method, aka using our random forest classifier, is could we improve the current model? Now in this case, if the model we're using performs well straight out of the box, which is what our random forest classifier does, can we improve the hyperparameters of this model to make it even better? Now a little note here is that patterns in the data you find, that our machine learning finds, is often referred to as data parameters. And the difference between parameters and hyperparameters is a machine learning model seeks to find patterns in data on its own. So a machine learning model will find parameters in data on its own, whereas hyperparameters are settings on a model that you can adjust. So we'll put this here. Parameters equals model finds these patterns in data, and hyperparameters equals settings on a model you can adjust to. Now we'll put this in brackets because this is a bit of a trial and error process to potentially improve its ability to find patterns. Now we've covered a fair bit of ground, right, just in this one cell before we've even seen to code, but this is kind of setting up the framework for what we're going to cover in the next couple of videos. So let's put that there. Oh, this is a little bit confusing here. I might put a little heading here. Hyperparameters versus parameters. Now, how do you find a model's hyperparameters? Well, that's a good question. Let's check it out. We'll go from Scikit-learn.ensemble import random forest classifier. CLF equals, we'll instantiate a random forest classifier here, random forest classifier. Wonderful. Now, once we have a model instantiated, you can find its hyperparameters by calling the function on it, getParams. Wonderful. Now, these are all different hyperparameters that we can adjust on our random forest classifier. And now, if you're looking at these and thinking, wow, this is a lot here, this is very confusing, I'll show you where you can find out more about each one. Well, let's go to Scikit-learn random forest classifier. Wonderful. So if we were to go through this documentation, what we're going to see here is parameters. Now, this can be where it gets confusing because I've used the word hyperparameters, but Scikit-learn kind of defines them as parameters. The reason why it's parameters here is because in Python terms, each of these is a parameter that you can pass this function to adjust. But in reality, these are hyperparameters. So this is where this list comes from. If we were to read through all of these, we could come to the Scikit-learn random forest classifier documentation and read through all of them and find out what exactly they are. Then if we come down here, Scikit-learn will include a few notes about the random forest classifier and little tips on how we can adjust the hyperparameters. Now the same goes for any other model that you might choose. If you click on any of these, you'll come across something similar like this, documentation which will tell you the model's hyperparameters that you can adjust. Okay, now you still might be thinking, I'm still not getting the concept of hyperparameters. And so we come to this little diagram. This may help your understanding. Improving a model via hyperparameter tuning. So if we imagine this food source here as our data, and what we want a machine learning model to do is figure out the patterns that it can use to make our favorite dish. If you're cooking your favorite dish, if this is you cooking here, not a machine learning model, what you might find is that if you put the oven on for 1 hour at 180 degrees, your favorite dish, the roast chicken dish, doesn't come out exactly how you want it. But after a little bit of practice, after a little bit of trial and error, you find that if you cook it 1 hour at 200 degrees, your dish comes out exactly how you want it. Perfect. Now, the analogy here to understand is that in our case, adjusting hyperparameters is like adjusting the temperature on the oven. Our initial machine learning model, straight out of the box, may be this oven here, cooking at 1 hour at 180 degrees, and it may find some patterns in how to combine these ingredients together to get our favorite dish, but it might not be just exactly how we want it. So what we do is we try a few different parameters, a few different hyperparameters, and eventually we figure out we want to change the temperature to 200 degrees, and that brings out our perfect dish just the way we like it. The same thing goes with our machine learning models. If we just used our random forest classifier as it came out of the box with its default parameters, these ones here, it may find patterns in our data pretty well, which it is. It's doing about 85% accuracy. But what we might be able to do is adjust these, much like our setting on our oven, and so that it finds these patterns in the data a little bit better than what it does straight out of the box. Now, again, this is a lot to take in, but don't worry. It took me a while to understand this concept as well. So we're going to look at, over the next few videos, 3 ways to adjust hyperparameters. The first one is by hand. So we'll try and tune them by hand. The second one is randomly with random search CV, which is a function in Scikit-learn. And the third one is exhaustively with grid search CV. Okay, so have a little bit of a read over this. Just read through here. If you don't fully grasp it yet, that's completely fine. But just remember, this is what we're going to cover in this section. We're going to improve a model focused on hyperparameter tuning, and hyperparameters are settings on a model you can adjust to potentially improve its ability to find patterns in data. Much like if you were cooking your favorite dish, you might adjust the temperature of your oven from its baseline setting of 180 degrees to get the perfect outcome of your favorite dish. So keep that in mind, and I'll see you in the next video.